The wood is sourced from essential forest thinning programs and sawmills as chips. For the production of sack kraft paper, we use long fiber wood, which ensures highest paper strength. For the production of specialty kraft paper, a mixture of short fiber and long fiber wood is used to ensure both high paper strength combined with excellent surface and optical properties. First, the long wood is debarked in a rotating drum by friction, generated by beating the logs against each other and against the drum wall. The removed bark falls through slits in the wall of the debarking drum onto a conveyor belt, which carries it away for storage prior to burning in a bark boiler to generate electricity. The debarked logs leave the debarking drum and are transported to the chipper for cutting. Since uniform chip size is important for achieving consistent pulp quality, the chips undergo thickness screening before storage. High-quality pulp is produced from a careful blended mixture of forest thinning and sawmill chips. The primary task of the pulping process is to separate the fibers by using cooking chemicals. This illustration shows a continuous sulfate process beginning with the chip bin, where the chips arrive from the woodyard. After the chip bin, the chips enter the low-pressure part of the process, the steaming vessel, where the remaining air in the chips is pressed out. Upon leaving the steaming vessel, the chips enter the high-pressure part of the pulping process. In this stage, pressure of up to 14 bars is used in the impregnation tower to fully penetrate the chips with cooking liquor. After impregnation, the fully soaked chips are transported to the top of the digester, where cooking starts. Cooking takes place from the top to the bottom of the digester. In the lower part of the digester, the cooking process is stopped by washing liquor. In the following washing stages, the lignin compounds dissolved in the cooking liquor are washed out of the pulp. Around 99% of the used cooking chemicals are recovered. During this process, both steam and electricity are produced. In the final stage, the washed pulp is screened before being used in paper production. The paper-making process in the paper mill begins in the stock preparation plant, where the pulp is prepared by beating in refiners at different consistencies. Necessary chemicals are also added here. After screening and dilution, the highly diluted fiber solution passes through the head box to the wire section. The state-of-the-art dilution water head box is equipped with a number of valves across the whole width of the paper machine, which regulates the basis weight profile by adding defined amounts of dilution water as required. This modern computerized technology ensures even profiles across the whole width of the paper machine. The wire section consists of an endless running wire and dewatering elements. The highly diluted stock comes out of the head box and is evenly distributed on the running wire. The fibers remain on the wire while the water goes through it. At the beginning of the wire section, dewatering takes place without a vacuum. But in the lower part of the wire section, the dewatering elements are assisted by a vacuum. The extracted water is recycled for use in diluting the pulp. At the end of the wire section, the wet paper web is transferred from the pickup roll via a felt to the press section. The paper web passes through the press section, where its dry content is increased by squeezing between press rolls. This illustration shows a 3-nip compact press. The paper passes through the press nips, where water is pressed out and the dry content increased. Depending on the layout of the press, the extracted water is taken up by suction press rolls. and/or felts containing the water transport it away from the pressing zone. After the press section, the paper enters the drying section. Here, the paper is dried by a number of steam-heated drying cylinders. As a result of the high consistency beating during stock preparation, the paper shrinks during drying, but only in the cross direction. The more the paper shrinks, the greater the stretch. To achieve high stretch in the machine direction as well, the paper passes through the Klupak unit, where the paper is micro-crept. Reducing the speed of the post-drying section retains the micro-crep effect, which gives the paper stretch in the machine direction. The lower the speed of the post-drying section, the greater the stretch in the machine direction. After leaving the Klupak unit, the paper is dried to the specific final moisture content. Before winding, the paper passes a scanner, which scans the moisture and basis weight profiles.